Assalamualaikum. My name is Iman Haziq bin Talib Sabri, metric number 2312861.
And my name is Muhammad Arsyad bin Azahari. My metric number is 2311901. And today we are gonna share with you all about the electrostatic. For the contents of this video is the firstly is about the electric force, secondly about the electric field, next is about the electric potential, and lastly is about the electric potential energy.
Moving on to our first topic, what is electric force? The repulsive or attractive interaction between any two charged bodies is called an electric force. The electron force between two electrons is equal to the electron force between two protons when placed at equal distances. This describes that the electron force is not based on the mass of the object, but depends on the quantity known as the electric charge. Next, what is Coulomb's law? Coulomb's law is an experimental law that quantifies the amount of force between two stationary electrically charged particles. The electric force between a stationary charged bodies is conventionally known as the electrostatic force or Coulomb's force. Coulomb's law states that the value of the electrostatic force of interaction between two point charges is directly proportional to the scalar multiplication of the charges and inversely proportional to the square of the distance among them. What is the formula for electric force? Electric force formula can be obtained from Coulomb's law as follows. F equals to K times Q naught times Q1 over by R square times by R hat, where F is the electric force directed between two charged bodies. K is the constant of proportionality. Q0 and Q1 are the amounts of charge on each body. R is the distance between the charged bodies. R hat is the variable unit vector. As for the SI unit for electric force, the electrical force, like other forces, is generally measured in Newton units. Applications of electric force. First, the charge in a bulb. Second, electric circuits. Third, static friction between cloth when rubbed by a dryer. And fourth, the shock that is felt after touching a doorknob. Next, what is electric field? Electric field is defined as the electric force per unit charge. The direction of the field is taken to be the direction of the force it would exert on a positive test charge. For example, the electric field is radially outward from a positive charge and radially inward from a negative charge. What is the formula of electric field? The electric field formula is given by E equals to F over by Q. E represents the electric field, F represents the electric force in newtons, and Q represents charge in coulombs. Electric field strength is measured in SI unit volt per meter. Applications of electric field. First, we have electron microscopes. Electric fields are utilized to control the trajectory of electrons in electron microscopes, allowing for high-resolution imaging of small objects. Next, we have electrocardiography, or known as ECG. Electric fields produced by the heart are measured by electrodes placed on the body surface to monitor heart activity and diagnose cardiac conditions. Up next, we have electroencephalography, or more popularly known as EEG. Electric fields generated by the brain are recorded by electrodes placed on a scalp to measure brain activity and diagnose neurological disorders. And lastly, we have particle accelerators. Electric fields are used to accelerate charged particles to high speeds in devices like linear accelerators and cyclotrons for fundamental research and medical applications.
Next, I want to explain about the electric potential. Electric potential is the amount of work energy needed per unit of electric charge to move the charge from a reference point to a specific point in an electric field. The unit of electric potential is in the International Systems of Unit (SI units) is the volt, which is equivalent to joules per coulomb. In electrostatics, the electric field is a vector quantity that is expressed as the gradient of the electrostatic potential. This relationship allows for the calculation of electric potential in both static and dynamic electric fields. The electric potential at the reference or any point is defined as zero. The electric potential at any location in a system of point charge is the sum of the individual electric potentials due to every point charge in the system. Electric potential can be calculated using the Coulomb's law, which is the equation for electric potential is V is equal to KQ over R, where K is the Coulomb constant, Q is the charge of the point source, and the R is distance from the point source. And for the applications of the electric potential is in the electrical devices such as TV screens and electron microscope. Electric potential also is applied in the batteries. And lastly, electric potential also is used for the measurement of electric potential such as the voltmeter. The last content of this video is about the electric potential energy. Electric potential energy is the amount of work done to move a charged particle from a reference point to a specific location within the electric field. The unit of the electric potential energy is joule, which is a measure of energy. This concept is crucial for understanding how charged particles interact within electric fields and for calculating the work done by the electric field on a charged particle as it moves from one point to another within the field. The equation for calculating the electric potential energy is given by U is equal to K Q1 Q2 over R, where U is the electric potential energy, K is the Coulomb's constant, Q is the point charge, and the R is distance separation. One of the applications of the electric potential energy is in the electrostatic machines. Devices like Van de Graaff generator accumulate charge and create high voltage. The potential energy stored in this machine can be used for experiments or demonstration. Secondly, electric potential energy is also applied in the particle accelerators, such as cyclotron and linear accelerators that use the electric field to accelerate charged particles. The potential energy is converted into kinetic energy, allowing the particles to reach high speeds. And lastly, electric potential energy is applied in the solar panel, photovoltaic cells. Solar panels convert sunlight into electricity by utilizing the potential energy of separated charge. Sunlight excites electrons, creating a potential difference that generates electrical current. Thank you for watching this video. Till we meet in the next time.